A new, serious, infectious disease has just broken out in Brisbane and we need to act fast. There are many important questions being asked. How far is this disease going to spread? How many people are going to become infected? How long until this epidemic is over? In order to answer these questions, we need to build a mathematical model. We need the model to accurately predict the course of the epidemic so that we can prepare an appropriate course of action. When building an epidemic model, there are two very important numbers. The first is how many people do you come into contact with each day? Now, I'm not actually talking about physical touch. It actually includes all the people that you come close to during a day. So, for example, it's all the people that you're sitting near at the moment in this lecture theatre. Now, the more people that you come into contact with, the more people that you have the possibility of infecting. The second important number is how long before you actually recover from this disease. The longer you remain infected, the longer you're out there, possibly infecting other people. Now, the problem is that you probably don't come into contact with the same number of people each day. And from person to person, this number is probably going to vary quite a lot. And the same applies to the recovery time. We don't all recover at the same rate. So these numbers actually have some uncertainty in them. Now, we could go and choose some sort of average value, but that could cause our model to give misleading results. In my research, I'm looking at a new method. It's called polynomial chaos. Polynomial chaos allows us to insert this uncertainty directly into the model. And with the uncertainty in the model from the start, our results are much more accurate. Not only that, polynomial chaos is much, much faster than existing methods. Usually, if we wanted to include uncertainty in the model, we'd have to run the model thousands, even tens of thousands of times, and then average our results. Polynomial chaos, what I'm using, we solve the model once. This is a huge speed increase. Now, polynomial chaos is not just for epidemic models. It can actually be used in any model where there's uncertainty in the parameters. So by using polynomial chaos, hopefully our model will be accurate enough for us to properly prepare for the coming epidemic. Thank you.